Dear student, this is the part 3 of this chapter, image operation and histogram. And we're still in the course Introduction to Image Processing. So now we'll talk about piecewise linear transformation function, which is a complementary approach to the transformation function that we have taken before as logarithmic function, exponential function, and gamma function. Their advantage that this function can be arbitrarily complex, but their specification require considerably more user input. So we need to enter more data or to make more specification in order to apply this function. So we have three precise linear transformation function as contrast stretching, gray level slicing, and bit plane slicing. So we talk about this during this video. So as you know, histogram is a plot of relative frequency of occurrence, which means that in histogram, we count the numbers of elements that have same values, and we make a plot, each value, how many times this value is present. So if we apply this into the image, so we obtain a discrete probability function that describes the likelihood of pixels of the probability of pixels, which means that, for example, the pixel number 5, how many times this pixel is present in the image. The pixels that have the value 6, how many times is present in the image. And as you know, if we have a gray level image, so we have pixels between 0, which is the black, to the value 255, which is the white. So, and each value, we count these pixels for each values and we obtain an histogram. So the function is histogram of Rk equal nk, where Rk is the kth gray level. And as we said that for gray level Rk starts by 0 for the black until 255 for the white. So for the pixels number, for the pixels that have 0, we have the number of pixels n0, which is the number of pixels that have value 0. For R1, which is the number 1, how many pixels have 1, and so on. So nk is the number of pixels in the image that have Rk gray levels, and as we said, for 8-bit gray level, we have k from 0 to L minus 1, and L is 256, so we have from 0 to 255. And this is the histogram for any data any data. So in order to study any vector of data or the data from any observations, so just we count, we order the values by increasing order. Then for each value, we count how many times this value is present on the data in the database. And in this way, we can take an overview about the distributions of each pixels on the image. So for example, if the low values have a great occurrence, which means that the image is dark. If the high values of Rk, which means that 255, 254, 253, and so on, are more frequent on the image, which means that the image is bright, and so on. Sometimes use normalized histogram. Rather than use the number of pixels, we can take the percentage of this pixel, which is simply the number of pixels over n, the total number of pixels. So nk is the number of pixels that have the value Rk. It's divided by n, which is the total number of pixels. So rather than using or saying that we have, for example, uh, 100 pixels have the value 5, we can say that the percentage of the value 5 is, let's say, 4%, and so on. So in this case, the sum of components of probability is 1 because the summation of nk is n, so total number is n divided by n, which is 1. For MATLAB function, we can use the function image histogram that gives the histogram of an image. So the histogram is in general is a simple and popular tool that is used in real-time image processing. And by statistics, it provides a useful tool for the image. For example, it reveals basic contrast present in the image, which means what are the values that are present in the image. As we said, if all the values or the majority of values have low values, it means the image is dark. If the majority of pixels are of higher value, it means that pixels if white, and so on. So we can see, for example, how many number of pixels is dark, how many number of pixels is bright, and so on. And it show also the potential difference in color distribution. If I want to make, for example, a binary image, I want to divide the image into two categories. I can see the distribution of the two categories and see what is the value that can be selected as a threshold value to differentiate between the foreground and background. And also the histogram is based, it's the basis for numerous spatial domain processing technique, for example, image enhancement. If I want to enhance the image, differentiate between two colors, so I make the histogram help me to differentiate between different colors as background, foreground, or if the image contains many colors that each colors represent an object on the image. This is what we call image segmentation. And also the histogram can be used to make image compression where the pixels of higher occurrence can be represented by low number of pixels and so on, which is, for example, similar to the Hamming code. So let's take an example. This is a image read coins.png. This is the image. Now we make figure image histogram. So this is the histogram. And as you see here, for example, for the bit 0, we don't have any pixels, 1, 2, 3, etc. Between, let's say, 40 and 50, the number of pixels is around 20 or 25. After 50, it's 20, 50, 60, or 70. We obtain 800 pixels. For example, here we have pixels of 1060 at, let's say, 65, etc. And here also we have another pixels at 100, let's say 75, of value 420, and so on. So this is the histogram. And here we can see a peak on the lower range. This peak on the lower range that correspond to the background intensity. And also we have another peak at the higher value that represent the foreground intensity. This is peak correspond to the black color. So we have the number of black is popular here. And this black correspond to about 60, between 55 to 70 approximately. And we have a white, and we can see here we have the white is between let's say 125 till 225, this part, because the white colors is here we have a white colors that here dark. Here we have a bright white color. So for that we have this as histogram. And as we said before, by studying the histogram, we can say, for example, we can divide this image into two classes, the class foreground and background, by taking, for example, the threshold values that decompose the image into two classes. For example, at this position, at the value 100. Also, the use of histogram show me the distribution of the pixels around the axis from 0 to 255. Also, we can use rather than use image histogram, we can take number bin image histogram, which give me the number of gray level that are present into the image, which is between 0 to 255, and number give the number of pixels for each value. So by writing number bin equal image histogram, it gives me two vectors. The first vector, which is the bin vector, it represents the value that are present into the image, which means that from 0 to 255, if we consider that all the colors are presented on the image, and the vector numbers that for each value, it gives the number of occurrence. So, for example, if I want to know 100 RK, which is 100, how many pixels are, just I have to find number 100, which is give me that's 41, which means that we have 41 pixels in the image that have the value 100. This is another example we're using histogram. Here we can see that we have three peaks. The middle peak, which is the majority of pixels, is about the background, which is this the view of the land. While here we have a slight peak for dark color that represent this part of the image, this part of the airplane, and the dark part here, also the wheel. And here we have the white peak, a small white peak, which is this part, which is lighted by the sun, this part and this part. So we have a small peak. In the first example, we have two peak. So we can divide the scene into foreground and background. So it's clear. I can make here a classification and can divide the image into two classes. But in the second example, we don't have two classes, just we have three classes. The center class, which is the majority of the pixels. Then we have two small peaks at the dark side and at the light side. So here, the decomposition of the image into two classes or binary, it's very difficult in this example, while it's very simple in the first example. So the image histogram, as we said, it's a plot where x-axis range of value from 0 to L minus 1, which is from 0 to 255, and y-axis give the number of times each value is presented on the image. So in the first example, seen with a clear bimodal distribution, which means that bimodal, which means we have two mode or two pick. In this example, which is the first example, we can select simply the best threshold value, and we can separate the foreground from the background the simple way. While seen with complex histogram, as we have seen here it's a complex histogram. We don't have two pick, we have three picks, where the intermediate pick is very is huge. So when the scene is a complex histogram, sometimes we have to apply sophisticated segmentation method like Gaussian filters and others in order to try to change the histogram of the image and to be more adaptive to apply thresholding algorithm in order to divide the image into two classes. So for that, we have the MATLAB function, gray threshold. The MATLAB gray threshold used what we called OTSO algorithm. OTSO algorithm is an algorithm that tried to find the threshold value with an automatic way. So its objective is to minimize the inter-class statistical variance of the thresholded black and white pixels. This is what we call the OTSO thresholding value. So let's say we have, this is the first class. This is the first pick. And we have another pick of values. This is Gaussian as normal distribution that you have to take about it with the statistical course. So this region is the overlapping between the two classes. This region, we have overlapping between the two classes. So here, if I want to make a distribution, it's very difficult to divide the image into two classes, because here in the overlapping region, how can know that this pixels belongs to this plot, or this pixel belongs to this plot? So it's very difficult. So also algorithm try to minimize the variance, which are the variances, which is the squared of the standard deviation, sigma of the Gaussian distribution. And by minimizing the variances, it means that we reduce the size of the overlapping region. So when we reduce the size of overlapping region, it means that we minimize the overlapping between the two sides, and we can improve the thresholding of the image when we want to transform this image into binary image. So this is the image histogram level equal gray thresholds of the image. Then we apply image to binary A level. This is applied to the coins and applied to the cameraman. We can apply this also to the camera. Adaptive threshold value. Now we need to overcome limitation of conventional and global thresholding by applying a local threshold. Is determined according to pixel values in the neighborhood. Now, what is the problem here? The problem, it may have a dark in the image. We may have a dark region and a lighted region at the same time in the image, and we want to select the best threshold value in order to transfer the image into binary image. So in this way, the image is not illuminated in a uniform way. So for that, we divide the image into small windows, and every window, in every window, we apply a thresholding algorithm, and in order to divide the foreground from the background, and after that, we obtain the image. So the threshold value in this case is calculated based on statistics, and this statistic is calculated over a small local neighborhood. For example, you can take T, this is the threshold value at the mean plus C, or mean minus C. T is the median plus C or minus C, maximum minus minimum over 2, and so on. And we add C just to overcome the problem of noise. يعني خلينا نحكي بالعربي شوي. إذا أنا عندي صورة بدي أجيب لها الثريشولد فاليو، فممكن تكون الصورة بمحل غامق وبمحل فاتحة كتير. يعني أنا عم بصور شخص بقلب البيت، جزء من الصورة بيكون معتم لأنه بقلب البيت، ولنقول وراه في شباك فبتكون الضوء مضوى، بتكون الصورة مضواية. فأنا لما بدي أعمل ثريشولدينج شو بده يعمل هو؟ بده يشوف وين الماكسيموم والمينيموم، وياخذ النص تبعهم أو المنطقة اللي بيناتهم. here we have a problem. ليش عندي مشكلة هون؟ إنه الصورة مضواية هي منا جزء من الصورة الحقيقية، والصورة من المعتمة هي منا من الصورة الحقيقية، وبالتالي هون راح يكون في عندي غلط باختيار الثريشولدينج فاليو اذا اخترت انا ثريشولد فاليو ثابت لكل الصوره. بالادابتاتيف ثريشولدينج شو راح نعمل نحن؟ كل ريجن، يعني باخذ انا الدارك ريجن بختار لها ثريشولد لحالها، اللايت ريجن الصوره المنطقه المضويه بختار لها ثريشولد لحالها، وبالتالي انا شو بكون عم بعمل؟ كل شقفه من الصوره عم بيطلع لها ثريشولد فاليو حسب the value of pixels، وبالتالي انا قسمت البيكسلز into small images كاني قسمت الصوره الكبيره لصور صغيره، وكل صوره عم جيب لها الثريشولد فاليو لحالها. وبالتالي we take all the characteristic regional characteristic or local characteristics of each part of the image. وبالتالي صرت عم بشتغل انا على شكل مصغر صغير، هيدي الشكل المصغر بتعطيني ثريشولدينج بطريقه افضل، لانه كل شقفه صغيره من الصوره عندها خصائص مختلفه عن الشقفه الثانيه من الصوره، وبالتالي كل شقفه صغيره بجيب لها ثريشولدينج لحالها and so on until لحتى اوصل للصوره الكامله. So for that مثل ما قلنا we take a local neighborhood، بنختار نحن for each pixels بدي اعرف انا كيف طبقها، بختار انا neighborhood around the surrounding pixels، يعني بعمل شباك لنقول 5 بيكسلز بالطول و5 بيكسلز بالعرض، بيطلع معي شباك فيه 25 بيكسلز. طبعا عدد البيكسلز بختاره كبير لحتى اخذ الريجيون، لاخذ اللوكال ريجن، وما بياخذه كثير كبير حتى ما يتاثر بالاناره العتمه او الاناره اذا كانت موجوده بالصوره اللي هي مش لازم تكون، حتى ما تاثر على to not affect the choice of selected value. So for that we apply what's called image filter. So image filter AH replicate. A هي image H is a filter، بختار a type of filters. هلا we will say what are the type of filters. And image filter AH filter the multi-dimensional array A with the multi-dimensional filter H. So we create a filter, then we apply the filters on each size or each region of the image. replicate شو بتعني؟ بتعني ال boundary pixels are assumed to be equal to the nearest array border value. يعني أنا إذا أخذت هيدي الصورة، إذا أخذت أنا شباك this is the image and for each pixel شو رح نعمل نحن؟ for each pixel we divide the image into window. هذا هو الويندو الصغير اللي أنا باخده. So this is a small window. We apply the threshold value on this window. طبق أنا الثريشولدينج على هالشباك الصغير، برجع على شباك تاني حده، وهكذا دواليك لحتى تخلص all the image. Now إذا كان عندي هون أنا إنارة قوية كتير ما بتتأثر فيها هذا الشباك، وبالتالي هون بكون أنا عم بختار the best thresholding value without to be affected by the luminance or the darkness on the image and on the other region in the image. طيب هلا اذا انا عندي بيكسلز، النقطه البيكسلز كيف بتشتغل؟ باخذ البيكسلز الموجود at the center هيدي اللي بالنص and we apply a filter. طيب هلا الصوره النقطه اللي موجوده على البوردر، يعني على الطرف the first row or the first column the last row the last columns، ما في يطبق عليها شباك، لانه انا اذا بدي اخذ هيدي النقطه واعمل شباك وبالتالي بده يصير الشباك خارج الصوره. فمشان هيك the border pixel شو بنعمل؟ This is pixels that can be calculated. The other pixels that are nearest the border بتغير الفاليو حسب آخر أو أول value can be calculated. So this is what we call the replicate. H it's a filter, so we have H is a filter, so we have different kinds of filter. So F special creates a filter specified type, بدنا نعطيه size of filter. How with the size of the filter 3 5 5 6 7 8 9 etc. And we give the type of the filter because each type of filter have a specific type. So we have the average filter, Gaussian filter, Laplacian filter, motion filter, disk filter, and logarithmic uh, Laplacian of Gaussian filter or log of Gaussian filter. So this is we need rice, image filter A. This is H, which is a F special average 1515 on the size of the filter. Replicate and type is average. So after make the filter by نعمل image filter, we take the original filter and we differentiate it from the filtered image, and we add a constant C or differentiate the constant C. After that, we can apply the binary functions that transform the image into binary image. So this is the original. This is the mean image. Now, after subtraction, we obtain this image, and when we make the binary image, we obtain this image. طبعا عم نشوف the performance of this image based on this value. فإذا الادابتيف thresholding it's very important. ولناخذ example، إذا أنا عندي منطقة دارك يعني رح يطلع الافريج اوف ذا داركنس لنقول 50. واذا عندي منطقه ضوئيه رح يطلع الافرج لنقول 220 او 210. هلا لما نقص كل بيكسل من الدارك من المين فاليو رح تطلع بالمنطقه الديفرنس هو قليل. واذا بروح على البرايت ريجن كمان رح نقص الفاليو اوف بيكسلز فروم اتس مين، وبالتالي رح يطلع الديفرنس كمان قليل. وبالتالي in this way we can obtain a subtracted image. In the subtracted image كل البيكسلز that are near the mean values will have low difference، وكل ما أنا أبعد عن المين value رح أحصل على higher value. So also we can apply median filter. Image read put image mid filter, which means that median filter too, with size 1515. Then we take the image and we differentiate it from the filtered image, and as we add a constant C equal 20. So this is the original image. This is the median image here after subtraction and after binary image. طبعا the constant C is affected هون. عم نلاحظ الصورة منا واضحة. the constant C منا منيحة. ممكن الميديان filter is not good to be applied on the image. On the binary image is performance منيح. So by applying mean image it's very useful to use mean image, while here by applying the median filter for the put image, which this is the image of put, ما كانت منيحة. So for that we have to select which filter is the best or gives the best results in order to use it and to be adopted in the when we process the image. يعني نحن لما نعمل ندور على الثريشولدينج نجرب عدة طرق ونشوف what is the best method that is that correspond to the desired image, and we use this image when we want to apply a thresholding algorithm. فنحن بدنا ندور بنشوف اي احسن algorithm وشو هن احسن parameters بتتناسب مع الصوره, because each image has its proper features and characteristics. كل صوره عندها ميزه خاصه تميز عنها. Contrast stretching is used for contrast stretching or normalization. طيب ليش أنا بدي استعمل contrast stretching؟ We want to stretch the range of pixel intensity to occupy large dynamic range. تخيل we have an image and this image in grayscale image, the minimum should be 0 and the maximum should be L minus 1 which is 255. فإذا بأي صورة in gray level المفروض يكون أصغر رقم 0 والأكبر 255. Now شفنا نحن in the first part when we apply logarithmic function and when we apply the exponential function كنت أنا عم بزيد number of we increase the range of the pixels by applying log and exponential. بس مرة كنت عم بكبر عدد عم بشتغل على الدارك سايدز على المنطقة الغامقة لما أكون عم بشتغل لوغاريتميك، ومرة بكون عم بشتغل على عم بكبر عدد الرانج بزيد الرانجز لما كنت عم بشتغل exponential for the pixels of higher values يعني near to 155. هنا this is what we have made when we apply logarithmic and exponential function. هلا نحن نعمل هالكونترا ستريتشنج لينيرلي، يعني مثل كانه انا عندي بردي مسكره وانا عم بفتح البردي لتغطي الشباك، فعم بفتحها بطريقه يونيفورم تكون يونيفورم for every value in the for every pixels. فبينما باللوغاريتميك فانكشن بكون عم بفتح اكثر الميل الغامقه وعم بزم شوي الميل الفاتحه. بالاكسبوننشال بالعكس بكون المنطقه الفاتحه عم بفتحها كثير والمنطقه الغامقه عم بزمها شوي. هون لا لينيارلي عم بفتحها لينيارلي in the same distribution same percentage. So this is the formula I output equal I input minus C, A minus B, C minus D plus A. C, D are the maximum of the current image. وبالطبع ال A and B are the minimum and maximum of طبعا theoretical maximum and theoretical minimum of the image. So this is a contrast stretching. If R1 equals 1, R2 equals 2 معناتها ما عملت stretching. If R1 and R2 equal M, which means that these two values belongs to the same value, and if S1 equals 0 and S2 equal L minus 1 يعني راح أحصل على شكل near Z for example شبيه بالZ but reverse, and in this way بكون عم بشتغل binary image because the output image has two values يا اما 0 يا اما L minus 1, and the best method is when R1 is less than R2 and S1 less than 2 we produce various degree of spread of gray level in output image. So we stretch the gray level linearly. هون ما في تمييز الدارك واللايت بطريقه linearly كلهم عم يتمددوا بنفس الدرجه. And إذا كان عندي R min and R max we expand this into obtain 0 L minus 1. يعني let's say نرجع شوي على الصورة هون لحتى وين كنا عم نشتغل هيستوجرام. ناخذ هذا الإكزامبل just to understand what we are talking about. هون عندي ال R minimum which is the minimum value of this image. Let's say أصغر value هي هون أو هون. Let's say this is the minimum value that are presented about 25 let's say. Well, maximum which is our maximum let's say 200. عم بتخيل إنه هيك 200. So معناتها في عندي from 0 to 25 ما عندي ولا أي pixels و from 200 to 205 ما عندي ولا pixels. وبالتالي الرانج اوف فاليو اوف بيكسلز مجموعه الارقام اللي انا عم بشتغلهم كبيكسلز هن بين ال 25 وال 200. So the range which is the maximum minus minimum هي 200 minus 25 which is 175. 175 بيكون الرانج. while لازم يكون 255 minus 0 يعني 255 values. So مش هيك نحن شو رح نعمل؟ رح نعمل stretching. بنوسع الفاليو اوف بيكسلز لحتى linearly بطريقه مونوتون كلهم عندهم نفس الستريتشنج الهدف انه يصير عندي all the value the colors all the colors are used، وبالتالي بستعمل كل الالوان من الصفر ل 255 and in this way we increase the performance of the image. Okay, so here we apply the contrast stretching. This is before stretching, this is after stretching. Of course, we can see the performance of this image when we compare it to the original image. And after stretching, we make a binarization. So we apply a binary image or thresholding algorithm in order to transform the image from a grayscale level into binary. Now the question is how to find the minimum and maximum. If I want to make a stretching, I want to determine what are the minimum and maximum of the image. And after that, the minimum will be replaced by 0 and the maximum will be stretched to be 255. يعني أنا الصورة اللي عندي الصغير أصغر فاليو بدي انقلها للصفر وأكبر فاليو بدي انقلها لل 255 مثل ما حكينا، كأنه أنا عندي برداية على شباك وهالبرداية ضبة على حالها شوي، فأنا لحتى أقدر أغطي كل الشباك اللي هو من from 0 to 255 لازم أول ميلة من البرداية اللي هي عندها فاليو مينيموم اللي هي المينيموم، يعني لنقول 30 فور اكزامبل، بدي شدها لتصير صفر، وبدي اروح على الماكسيموم value of the image لنتخيل الماكسيموم هي 230، بدي كمان اعمل لها stretching من 230 ل 255 اللي هي الماكسيموم value theoretical value الماكسيموم theoretical value. فاذا كيف بدي احسم المين والماكس of the pixels؟ So I can use the mean function and max function. So first the first method is to calculate the minimum and maximum. شوف شو أصغر رقم بالصورة وحوله لزيرو، وشو أكبر رقم بالصورة وحوله ل 255. مشان هيك we use the function mean and max. فإذا بالماتلاب we have two functions, the function minimum which is min and the function maximum which is max. And why we use I to points? Because we need to transform the m into vector. فمشان هيك we select to point because okay. So this is the idea. We can select the minimum and maximum of the image by using mean and max function. But if we take this, we encounter the problem what we call salt and pepper. What means salt and pepper? ممكن أحيانا the image have some disturbance يعني الصورة بيصير عليها تشويش. هالنوع من التشويش is called salt and pepper، يعني مثل كأنه واحد رشش ملح وقرفة على قرفة صودة على الصورة. So some pixels في بعض البيكسلز بيحملوا الوايت وهو الملح 255 and some pixels بيحملوا الفاليو 0 which is the black اللي هو القرفة أو الفلفل. فمثل كأنه أنا we have an image and we put some salt and pepper، كأني رشيت أنا على الصورة ملح وقرفة صوتي. فإذا بهالحالة the minimum راح يكون 0 which is the value of pepper and the maximum will be 255 which is the value of the salt. وبالتالي أنا عندي عدد صغير كثير من الفاليو اللي قيمتهم 0 وعدد كثير صغير من الفاليوز اللي أخذوا قيمة 255، ولكن these small values of 0 and 255 affect my contrast stretching، بيأثر على الكونتراست ستريتشنج تبعي. ليش؟ لأنه البرداية بمجرد ما في فاليو 0 ما عادش أنا شد على الزيرو، والبرداية صار الماكسيموم 255 ما عادش عم شدها من الميل الثاني على ال 255، وبالتالي ما عادش عملت ستريتشنج بسبب وجود عدد قليل جدا. فإذا just to resume the problem of salt and pepper. مثل ما حكينا نحن عندي برداية، نتخيل هذا شو هو الكونتراست ستيتشنج، هي فينا نتخيله بهذا الشكل مثل ما قلنا. عندي برداية بتغطي شباك، الشباك الميل الأولانية هو الصفر والميل الثاني هو الماكسيموم 255. فأنا بدي مد البرداية لتشمل كل الشباك، وهيك بكون أنا استفدت من الكل رانج اوف كولرز، كل عدد الألوان الكلي من الزيرو ل 255 إذا عم نحكي عن جراي. هلا لنتخيل أنا المينيموم هو 50 اللي موجود بالصورة، وبالتالي في أعمل أنا ستريتشنج واستفيد من الفاليوز فروم 0 لل 50، يعني الأرقام من الصفر لل 50 هودي ماني مستفيد منهم. فأنا لما أعمل ستريتشنج كونتراست ستريتشنج بستفيد منهم. هلا إذا عندي بيكسل وحدة بس قيمتها 0 ما عاد في اعمل ستريتشنج. واي؟ بيكوز لما انا عم جيب المينيموم اوف اي هون رح تطلع قيمتها 0، وبالتالي رح اتخيل او افتكر انه الرانج فروم 0 لل 50 عم استخدمها، بينما انا فعليا عندي بيكسل بالغلط اخذ قيمه 0 بسبب عمليه التقاط الصوره، الكابتشرنج اوف ذا ايمج، او من خلال عمليه الباينرايزيشنز، او من خلال عمليه الكوانتيفيكيشن، او عمليه التخزين، او عمليه الترانسفير اوف داتا. ممكن يصير في عندي خطا على الصوره. ونفس الشيء بمثل الماكسيموم. if we have the maximum is 230 for example, I can stretch the pixels from 230 to 255، وبالتالي بستفيد من الرانج اوف colors اللي هن من بين ال 230 and 255. now if we have 1 pixels قيمتها 255، بالنسبه لي لما عم جيب الماكسيموم فانكشن رح يطلع الماكسيموم هو 255، لانه عندي 1 بيكسل بالغلط صارت بيضة 255. فمشان هيك ما عاد اعمل ستريتشنج، وخسرت انا هيدي الرانج فروم 230 ل 255. هذا البروبلم مثل ما قلنا بنسميه سالت اند بيبر، لانه بيكون عندي نقاط بالغلط بيضة موجوده بيمثلوا الملح اذا بدكم، والبيبر هو مجموعه نقاط صغيره قيمتهم تساوي الصفر بيمثلوا البحر. وبالتالي I have to select another technique in order to find the minimum and maximum in another way. So this is an algorithm. The I equal m read 8. This is 8. We add a noise called salt and pepper with the percentage to percent. فإذا عندي function we can add a noise to any image. So this is image noise and this is salt and pepper. So طبعا هون أخذت percentage to percent عالي شوي just to show you the presence of white and pepper. As you see here, we have some pixels that have the white color, which means that 255, and some pixels have 0, which represent the pepper. وبالتالي by using this methods رح تعطيني مشاكل because لما عم جيب المينيموم رح يعطيني 0، ماكسيموم رح يعطيني 255، وبالتالي there is no stretching to be done. The second method لحتى اتخلص من the problem of salt and pepper is to use the 5 percentile points of the cumulative distribution, which means that we take 5% of image pixels less than C, and D with 95% percentile points of the cumulative distribution. So بكون أكيد أنت خليت عن 5% of the image pixels greater than D. يعني شو راح أعمل أنا بالصورة؟ راح أخذ المين هو أول 5% من البيكسلز، يعني بقسم البيكسلز من الصغير للكبير، اللي رقمها 5% او البوزيشن تبعها 5% هي اللي بعتبرها مينيموم، وبالتالي بيكون عندي انا 5% من عدد البيكسلز اصغر من هذا المينيموم. ونفس الشيء فور دي بتكون 5% of the pixels are greater than D، يعني انا بكون نزلت عن 5 لغايه اصغر 5% من الداتا ولغايه اكبر 5% من الداتا، اللي احنا بنسميها سترينج داتا، اللي هي ال values that are illegal او illogic. فدايما احنا وين يكون عندنا داتا ستراكشر، داتابيز، لما يكون عندي انا مجموعه ارقام عملت لهم اوبزرفيشنز، عاده شو بنعمل؟ بنلغي اول 5%، نعتبرهم هودي الفاليوز ما انهم منسبين، and we delete the highest 5%، بنلغي اعلى 5%، and we take the data between the within 5 and 95%. ناخذ كل الداتا بين 5% وال 95%. كل الارقام الاصغر من ال 5% بنعتبرهم هودي ارقام فيهم غلط او ما انهم مقبولين، وكل الارقام اللي greater than 95% نفس الشيء. فور ذات in this case هون نحن بحالتنا راح نختار المينيموم هو اصغر رقم بعد ال 5%، والماكسيموم هو اصغر رقم او اكبر رقم بعد ال 95%. وبالتالي قدرنا نحن to overcome the problem of salt and pepper. قدرت نتجاوز مشكلة salt and pepper noise. Third part, how to select C the maximum and D the minimum. We select the most frequency occurring intensity value of N. نختار أكبر occurrence، يعني شو أكثر بيكسلز موجود بالداتا عندي. لنقول ال 30 موجود 500 مرة، هذا أكثر شيء. So بختار أكبر بيكسلز، بعدين بختار على يمينه وعلى شماله 5%. فإذا من البيكسلز اللي أخذ higher occurrence بختار على يمينه 5% بعتبره هو المينيموم، وبروح على شماله على الرايت سايد بختار ال 5% بعتبره هو الماكسيموم. So this problem is less robust to complex multi-peak histogram. ولكن هذه this case 3 can cause a problem إذا ما كان عندي one pick، إذا ما عندي pick واحدة، إذا عندي multi pick بهالحالة we will have a problem. فإذا the best method is the second method. أول method مثل ما قلنا we have a problem with the salt and pepper. هيدي حلينا قصة salt and pepper. The third method had a problem if we have multi-peak histogram، يعني عندي الهيستوجرام ما عنده 1 2 pick، ممكن يكون عنده 3 pick 4 picks and so on. So the third method is not very popular. So the second method هي the most used method. So we use the function stretch limit. stretch limit هو لحاله بحدد لي the minimum and the maximum. بعطيه الصورة وبقول له قديش البرسنتج بدي إياها. And this function determine the minimum and maximum. So it's find the limits to contrast stretch an image. Low and high specified by the fraction of the image. فإذا when I give 005 095 it means that I ask this function to give me the value of minimum, which is at the 5% of the data, and to give me the higher value, which is at the 95% of the data. And after that, we apply image adjust. We adjust I to the of new, low, and high, and we adjust the intensity of the image, and we map again the value of the image from min max to 0 to 155. So this is an example. Here we take the putative and we make an adjustment A, and here we put the min max, which are the output on the stretch limit function of value 5% and 95%. طلعوا هون. This is the image. هذا الكونتراست stretching. لاحظوا the minimum value on هي about 75. And the maximum value, let's say 180. And this is the image. After that, we stretch the histogram. يعني هاي البردية مثل ما قلنا كأنه هذا الشباك. This is the window. والشباك والبردية مسكرة على الميلتين، يعني شدينا على بعضها، مطعوجة بالنص هيك البردية على بعضها، مجمعة على بعضها. فنحن الآن بالكونتراست ستيتشنج شو بنعمل؟ This part هيدي الميلة من الداتا بنشدها لتصير زيرو، كأنه أنا هون شديت البردية فتحتها لتصير على أول الشباك، وهيدي الميلة من البرداية كأني أنا شديتها لحتى تصير على هيدي الميلة. وبالتالي هون the number of pixels اللي شايفين هالعدد البيكسل مجمع مع بعض هون cumulatively near the window of histogram مثل ما انكم شايفين هون. after stretching صار عندنا توزيع على ال different value of pixels from 0 لل 255. عملنا توزيع للبيكسلز، وزعنا العدد على كل الرانج of values. طبعا of course the performance of the image is and the quality is very good compared to the first image or to the original image. Okay, we stop here and we continue in the next part of the video.